Hello guys, welcome to the channel. Today we will discuss cross validation. Okay, so what is cross validation? Cross validation is a technique used to check how well our machine learning model will perform on unseen data, whether the model is overfitted, underfitted, or performing well. Is what it does instead of testing the model only once, cross validation tests it multiple times on different data sets. Means when we basically create a model of supervised learning, then we just basically split the data into two parts, training and testing, right? So there is there is one data for training data and there is one data for testing data, but it will it basically splits the training and testing both data into several parts. Okay, so and test that on all the splitted data set. Okay, why do we need cross validation? Because suppose you have 80% training data and 20% for testing data. Then maybe the test data was too easy, maybe it was so difficult. So in that case, accuracy may not represent the real performance, right? So cross validation solves this problem by changing the train test split multiple times. Remember this. It will change the train test split multiple times and taking average performance. Okay, for all splitted data set. Okay, how it is performing on all splitted data set. Okay, so so there are some ways of doing cross validation. First one is your K-fold cross validation. What it does, suppose you have 100 records and you have chosen K is equal to 5, then it will split the data set into five equal parts. Okay, so divide 100 by 5 is equal to 20. Okay, so each fold will contain 20 records. Okay, so first one, this is how K-fold cross validation works. Second one, stratified K-fold cross validation. It is used for classification problems. And suppose your data set is imbalanced. You have 90% data as cats in your output and 5% only for dogs. Okay, then in normal K-fold, it will create bad spread, right? Because you have only 5% of, right? And then stratified K-fold keeps same class proportion in every fold. Every fold means it, suppose it has splitted the data 10 times, then it will basically keep these two categories or these two classes into same proportion, no difference. Okay, so this is how stratified default cross validation works, and leave one out cross validation. Only one data point is used for testing and remaining all data points are used for training. What it means? Suppose I have five records. Okay, one, two, three, four, five. So what it will do in the first iteration, let's say one will be for testing and two, three, four, five. Remaining four will be for training. Okay. In the second iteration, you will have suppose two as your testing data and remaining one, three, four, five will be for training. And leave P out cross validation, in which in this cross validation we will give, suppose P is equal to 1, P is equal to 2 or P is equal to 3. In with respect to that P is equal to 2, 3, suppose we have given 2, then it will take two uh, two testing data from each iteration. Suppose I have five records and one, two, three, four, five, and I have given P is equal to 2. Then maybe it's suppose it will take 1, 2 for training. One, two for testing, and remaining three, four, five for training in the first iteration. In the second iteration, it will take suppose 1 and 3. Then you will have 2, 4, 5 as your training data. Okay. This is how leave payout cross validation works. We will see how we can use all these cross validation techniques practically. Okay, so suppose I have this data set. So I have CGP as my input column and package I have as my output column. Okay, so basically it is a regression data. So uh, I have second one stratified K-fold cross validation. It is used for classification problems, so it will not work on this data. But I will show you the syntax for this validation technique also. Okay, so let's see how we can do it practically. Okay, first I will import my pandas library as PD. Okay, now I will load my data set. Let's say I have data set. Okay, Uh, this is my dataset placement.csv. I will right click, copy path, control V. Now I will give data.head. Now my data gets loaded and these are my first three rows. Okay. So basically, uh, first I will make this data smaller because it will have multiple records, and when we will perform uh, leave one out, leave P out, then it will work very slowly because I have multiple records. So suppose I will create a new variable. In this, I will take only starting, I will take only starting 10 rows. Okay. Okay. And suppose I will basically split the data set into input and output. Basically, I will take input data into my X new and my output data package into y new. Okay, suppose uh, data I will take as I have only one input column and one output column. Okay, and I will take y new is equal to data package. Okay, now my data gets split into two parts. Okay, now I will import all four methods. Okay, scalar dot model selection import. First I will import leave one out. Leave one out. Okay. Second one, let's say I will take leave P out. Third one I will suppose take KFold. And last one, let's say I will take static. Although it will not work on this data set because this is the problem of regression and this stratified K-fold only works for classification. But although I will show you the syntax for this also. Okay. Stratified stratified K-fold. K-fold. Okay. Okay. Here we go. Spelling sticker. Capital O. Okay. I will take, I will copy paste from here. Okay. Now I've imported all this. Now let's take first one. Leave one out. Let me make an object for calling leave one out. I will call leave one out. Okay. Now I will I will give an for loop for. I will take train and test in lo dot split. I will pass my x new and y new. In my x new there is my input column, and in y new there is my output column. Okay. Now I will print my train and test. Okay. Train test is not okay, sorry. Yeah, you can see it. Okay. This is how it is splitted my data. Okay. Let's see. First one, my zero. You will not gonna find here zero. Here I have one. You will not gonna find one here. One is for training and remaining all for testing. Zero. Zero here you will not find. One you will not find here. Two you will not find here. Basically here you can see zero is for testing and remaining all these values are for basically training. This is for testing and these are all are for training. This is how it is splitted. Okay, one by one. Here you can see till 30, all the values it has taken one by one. Okay, so uh, I will not print it. Okay, suppose I will I will keep this as it is. Okay, now I will remove this. Okay, now first one I perform leave one out. Now how to perform leave p out? Let's take an object lp to call leave p out. Okay. Now here you have to give p is equal to 2, or, or whatever value you want to give. P is equal to 2, 3, 4, anything. Okay. So again make an I will make a for loop for train test in lp dot split x new comma y. Okay, same I will show you by printing it. Print, train, and test. Sorry, again I gave slash. Okay, let's see. First one here you can see 0, 1. It has taken as for testing and remaining all for training. See, you in this array, you will not gonna find 0 and 1 because 0 and 1 it has taken for testing. Remaining all are for training purpose. Okay. Here you can see 0, 2. 0, 2 will you will not gonna find here because it has taken 0, 2 for training testing here and these are for training. So this is how leave p out works. Okay. Suppose I will not print it. Okay. Now, third one. Let's take KFold. Suppose I will make an object KF. Okay. I will call my KFold. Okay. Now let's take an split. Mid means convert my data into let's take 5. Divide my data set into 5 equal parts. Okay. I will copy this simply. Okay. I will basically just put KF here. Sorry, I will have to print. Yeah, here you can see it has divided your data set into 5 equal parts, and these are 0, 1, 2, 3, 4, 5 till 39. It has taken for testing, and all these are for training. And then after 39, it has taken 40 to 79 for testing, remaining all for training. Okay, so this is how it is splitted my data into 5 equal parts, and it has taken uh, testing data by itself and training data by itself. Okay, 0 to 39 for the first iteration, and 40 to 79 for the second, 80 to 119 for the third, and 120 to 159 for fourth, and 198 till 198 for the last one. Okay, so this is how KFold works. Okay, although stratified will not work here because I have regression data and it only works for classification. But although I'm showing you the syntax, it will have the same syntax. I will call this. You will have to again give an split. Let's take is equal and split is equal to 5. Now just copy. It will throw an error. Okay, it will throw an error because give here escape. It will throw an error because this is a problem of regression and we are applying stratified k-fold for regression. Okay, this will not work. This will okay. I have done something wrong here. It is basically working here, but although we generally use stratified k-fold for classification. Okay, it is basically working by thinking it as a classification problem, but this is not my classification problem. This is my regression problem. Okay, although I have shown you how we can perform all the cross validation techniques, these four techniques, how we can perform. Okay, so that's all in this video.